Hello, and welcome to this little discussion about the absolute value. And I can say without hesitation that the absolute value is absolutely the most important function that you could possibly think about in pre-calculus or calculus, analysis, etc. It comes up all the time, and it's very important to learn how to work with the absolute value function. So first, let's define what the absolute value function is. As you know, the absolute value function is an example of a piecewise function. It is defined in two pieces. Its value is just x if x is bigger than or equal to 0. That is, if x is positive. And it's minus x if x is less than 0. Let's draw a graph. What this means is that when we look on the positive x-axis, this is simply the graph of the line y equals x. What you put in is what comes out. Okay? Now, if we extend the line y equals x for negative values of x, this line is negative. The absolute value function simply reflects this negative part up. And this reflection is given by y equals minus x. And this is the absolute value function. Why? Because the absolute value function measures distance. How would you take a number and like minus 5 and turn that into a positive number? Well, what you would do would be to take its opposite. Minus 5 is equal to 5. And that's precisely what this piece of the definition and this half are doing. When x is negative 5, this number up here is minus 5, which is 5. And that is the distance. This number here, 5, is the distance that this number is from the origin. The negative axis is a reflection of the positive axis, and so if we want to know what the distance of this number is, it's just this length, which is given by exactly by this height. They're the same. This length and this height are the same. Now we've drawn all over our picture, but hopefully you've got a pencil and paper and you can start doing this too. The most important thing to remember here is number 1, the definition, be able to write the definition. Number 2, be able to draw the graph. And number 3, understand that the meaning of this function is distance from the origin. Okay? So now let's consider the equation absolute value of x is less than a, where a is any number bigger than or equal to 0. If a is negative, then this equation has no solutions because a positive number cannot be less than a negative number. There are no numbers, there are no positive numbers that are less than a negative number. So the only situation that we need to concern ourselves with is when a is some positive number. So let's look at that situation. And in fact, let's draw the graph. This is our absolute value function. This is our origin. And here is our line y equals a. And you see that the solution of the equation absolute value of x equals a is indicated by these two dots here. And the solution are these two numbers here. Those numbers are a and minus a. Because it's true that the absolute value of minus a is equal to the absolute value of a, which is a, since we've assumed that a is bigger than or equal to 0. Okay? So that is the picture. The solution of the set strictly less than a, those are all the points here where where our function is strictly less than this function, indicated by the line y equals a. Right? The blue function is underneath the red function for all the values shown here. This value, for instance, does not satisfy that because the absolute value function is above the red line, y equals a. Only for those x's in here is the absolute value function underneath. This is a very important skill, being able to understand the relationship between x, f of x, and another function, say g of x, given here by our horizontal line. Okay? So notice that the solution of this equation, absolute value of x less than a, is given by the open interval minus a to a in interval notation. Okay? This is the solution. The solution to our problem, S, is this interval minus a to a. Okay? In just a little bit more generality, we could consider something like x minus a is less than epsilon, where again epsilon is some number bigger than or equal to 0, and a is any real number. Okay? You recognize that x minus a is simply the absolute value function, the v-shaped function, shifted from the origin to a. And therefore, our graph and our solution set are going to be very, very similar. Our points here are going to be a minus epsilon and a plus epsilon. Those 2 points are symmetrical about the point a, and you notice that the absolute value function is symmetrical. The v-shaped function is symmetrical about the point a. The absolute value of x minus a is symmetric around a, and x minus a less than epsilon is this interval here that is given by in interval notation by the set of points a minus epsilon, a plus epsilon. Now, I know that you've been waiting a very long time. You hate the letters. You want to see something with some numbers. So let's indulge you just now. Let's solve this slightly more complicated expression, 2x minus 3 less than 1/4. Okay? The first thing that we could think about here is that we could graph we could graph what this function looks like. So the question is, where is this function centered? This function is centered at the point 3 halves. This is where the absolute value function is centered. This portion of our graph is the line y equals 2x minus 3. This portion of our line is y equals 3 minus 2x. The last piece of our puzzle here is the line y equals 1/4. So let's draw that line. So that line is here, let's say. That's our line y equals 1/4. Okay? And what we're looking for is the endpoints of our interval which are given by solving two equations. On this half, we're going to solve the equation 2x minus 3 equals a quarter. That will find us this point. That's this point of intersection. And over here, we're going to solve this equation. 3 minus 2x equals 1/4. Okay? So take a minute now and solve those equations, and then you will have figured out the two halves, or the two ends, of the interval, the open interval, that is the solution set of this problem. Okay? And that's how it works.